This baby is 6 weeks old and very healthy. Very occasionally, newborn babies stop breathing, sometimes for just a few seconds, and this isn't a problem. It's called apnea. If breathing stops for longer than, say, 20 seconds, there could be a problem, and some parents like to monitor their babies when they're asleep, especially if the baby is underweight. This device, manufactured by Ferraris Respiratory Europe Limited, can detect the baby's breathing and will sound an alarm if breathing stops. We visited Ferraris' testing lab in Hertford.
This is the sensor pad which goes under the baby's mattress. This test rig simulates the breathing and movement of the baby. And this simulates the weight of the baby on the pad. When the simulator's on, the monitor's green breath LED will flash with each breath detected. If the baby stops breathing, the monitor alarm will sound. Once the baby starts breathing again, the monitor alarm will pick it up. The red apnea alarm will continue to flash to show there's been a cessation of breathing, but now it's okay. I can reset the monitor back to its original state. This is the sensor pad we use, the apnea monitor. I've cut it away so I can show you what it consists of. If you look inside, there's a dielectric which is charged up and encapsulated in some tape. And I can show you the component parts. This is the aluminium plate which is bent up, preformed and charged, then inserted into this tape to insulate it so it doesn't short out. The reason it's bent up is for the movement as the baby breathes on it and moves on it, and it sends it out back to the monitor. Once you've soldered your last component in the printed circuit board, you do an inspection of the solder joints, and similarly do an inspection of make sure all your components are in, and it's now ready for testing using test points on the edge of the board. Put your printed circuit board into the test bed, and it starts picking up all the breaths through the breath light. Then you follow your test procedure. Our first procedure is just to check the current, make sure it's not drawing too much current. Just turn the oscillator off and then just check the meter you're getting less than 1 milliamp, which you are. We can reset it then. So once you're satisfied with that, then you can do a timing check, and it's set on 20 seconds. So what we do is turn the oscillator off and put the timing clock at simultaneously, and then when it alarms, we should get our timing. And while you're waiting for the alarm to go, you shouldn't get any breaths at all detected. If there is, then it's obviously faulty. There's your 20-second delay. You see your red LED flashing, which is the alarm light. Now that'll keep flashing until it detects another 2 breaths or movements. So we'll do that. There's 1, there's 2. Now it should work normally again with the red LED staying on to show that it's been an alarm, but now it's reactivated. Then you just reset the red LED, so you're back to the original state. And then we do a check further down. It's a mid plate, it's a waveform to show what kind of output we got at a test point C2. Now if you see on the scope, it should be nice and smooth sine wave, and then within amplitude set on our test procedure. Testing our peak-to-peak waveform, we can see it's within our allowable limits, and it's in fact 0.6 of a volt.